What's good, everyone? Back here again with another video today. I hope you guys are excited to learn about igneous rocks as much as I am. If you haven't, check out last video that I posted that was discussing about minerals, and it's very important to understand minerals when we're talking about rocks. So, what is an igneous rock? An igneous rock is basically a rock that has formed from the cooling of magma and lava due to different tectonic settings. Now, magma and lava are two different things. Magma is basically molten rock inside of the earth, while lava is molten rock on the exterior of the earth. Speaking of inside and outside of the earth's crust, there's two terms I want to talk about: intrusive and extrusive. Intrusive is basically when igneous rock is formed on the inside of the Earth's crust, while extrusive is the same process, but the lava is cooled off, forming igneous rock on the surface. So, whenever we're talking about anything in geology, we kind of want to start off with the composition of the material. When we're looking at igneous rocks, we're looking at the iron magnesium versus silica ratio, and that influenced the density of the igneous rock. So if it has a high amount of iron magnesium, it will feel a little more denser compared to something that doesn't have much iron magnesium. Speaking of that ratio, still it does influence the color. So when I was talking about minerals, color was kind of not a useful thing to use when identifying, but with igneous rocks, it's very important. So I want to work my way up in percentage wise of composition of iron magnesium. So let's start at the bottom, and that is felsic. And felsic igneous rocks are light in color, like these two guys. So it's high in pinks and whites. You might have a few grays or clears, but regardless, it's light in color. Then we have our intermediate igneous rocks. So they're more dark in color. They might look salt and pepper like, or they might look pretty grayish in context. Then we have our ultramafic and mafic rocks. Basically, those rocks are very dark in color, and when I mean dark, that also includes the color green. Green is actually considered as the highest level of indication for a ultramafic rock. And right here would be a good example of ultramafic rock. Now, felsic, intermediate, mafic, ultramafic, it does have a number with them. I don't remember those numbers specifically, but I do know that the lowest content of iron magnesium is felsic, while the highest content is mafic to ultramafic. Speaking of minerals, right here is bonus reaction series. This is a very important chart to understand, especially if you're an igneous petrologist. Basically, you're saying igneous rocks. And so, basically, how you read a chart is as you're decreasing in temperature, these minerals will slowly start to form. So, whenever we're in a hot batch of lava or magma, we will start off with all the minerals from olivine to quartz. And as we cool down, these minerals will start to form and will leave the midst of the lava. Best example to think about is looking at a jar of M&Ms. So you have a whole bunch of M&Ms in this one jar, and we can say all the colors that are being pulled out is an example of the cooling of the magma. So let's start off with olivine. I want to take the olivine out of the mix of M&Ms. So I just pluck out all of the greens in the jar, and now all I have left is from augite to quartz in my jar. And so we continue on as cooling goes. So I wanted to take out the augite. So I take out all the reds out the batch. And now I'm left with X colors in my jar. And those X colors can range from hornblende to quartz. And this process continues on. Now, another thing with bow interaction series, it also tells you the stability of a mineral when it's being exposed to weathering. I will probably talk about that later on when I discuss sedimentary rocks, but you can still use this chart for other different ways. Now, texture is another important classification when we're trying to ID igneous rocks. And here are like the main ones that we have right here to the side. These textures are very helpful when you're trying to indicate the igneous environment. So the first texture I want to discuss is aphanitic. Basically, the aphanitic is a igneous rock that has crystal sizes that are small enough where you might need a hand lens or a microscope to see them. And basically, you will only see these due to rapid cooling on the surface or extrusive cooling of magma or lava. I'm sorry, when you switch with magma and lava a lot, sometimes you get tongue twisted. Next one I want to discuss is phaneritic. Basically, this forms intrusively in the Earth's crust. You have crystal sizes large enough to see with your naked eye. Then we have glassy. You will only see these in certain events, in certain conditions. Basically, this is the rapid cooling of magma or lava, and no crystals will develop. Then we have vesicularies. I don't like the vesicular texture because it just makes me feel weird. But basically, you only get these from the release of gases, and this is very common in high silica magmas and lavas. Then we have pyroclastic. Basically, you have different rock fragments unsubmitted together by volcanic ash. Then we have pegmatitic. These grain sizes slash crystal sizes are large enough where you can actually use a ruler and count like several centimeters in size, and they can get bigger. I definitely want you guys to Google cool pegmatites because I believe there was one in the Dallas Natural Museum where there was a pegmatite where the crystal size was like at least a foot long. Then we have porphyritic. Basically, you have one large crystal size, and around it, you have smaller bits of crystals forming around it. So I basically wanted to give you guys like a real life chart of how we classify igneous rocks based off of texture, which will indicate the environment based off of the crystal sizes, and based on the composition. So from left to right, we have from our ultramafic igneous rock to our felsic igneous rock. Also divided up from extrusive and intrusive. So the ones up top right here, these were formed in an extrusive environment, while the ones right here were formed intrusively or in the Earth's crust. And so, based off of that, we can easily identify our igneous rocks. All right, so let's take the skills that you guys just learned and apply it to identifying igneous rocks. So, let's do a quick summary. Composition, we can go based off of color. So, the lighter the color, the more felsic it is. The darker the color, the more mafic to ultramafic this igneous rock is. Another thing is texture. Texture indicates the environment which this igneous rocks form, and we can really just go based off was it intrusive or extrusive. So I'm going to use this igneous rock right here. This igneous rock is commonly found near Mecklenburg County, specifically right by UNCC. Apparently, I did not know this. This igneous rock is kind of rare
when we're talking about igneous petrology because you need to meet certain conditions. But I'm getting ahead of myself. So let's take a look. We see that we can clearly see the different crystal sizes on this igneous rock. So, with that being said, it took a while for this batch of magma to cool down to form this igneous rock. So, based off of that, we can say this igneous rock has a phonitic texture and was formed intrusively. Now let's look at the color. The color is about 50% black, 50% white, salt pepper look. And so with that information, you can narrow down this igneous rock. I'm going to just give you guys a few seconds to figure it out. Now, if you guess diorite, you're absolutely correct. Let's try another one. So this igneous rock came from South America, from the Andes Mountains. I was gifted this. So let's look at the color. The color looks felsic in nature. So this is light in color. And if we're looking at the texture, for most part, we can say it's aphanitic. Even though there's like a few large crystals that we can clearly see, we will still want to classify majority of the rock. So this does have an aphanitic texture. So since it has an aphanitic texture, we can say that this rock kind of cooled on the surface, or this is an extrusive igneous rock. So based off of that, I'm going to let you take a few seconds. Now, if you guess rhyolite, you're absolutely correct. Now, if you're from North Carolina and you're traveling within the Uwharrie Mountains, there is rhyolite that is black in color. I don't have a sample on me right now, but possibly in a future video when I'm talking about the history of North Carolina or whatnot, I can throw that in there. So this big boy, I was gifted this, and I was told that the previous professor who was doing research on this rock got it from Greenland. So that's a big hint right there if you can figure out what this igneous rock is. But let's do it as the scientific method. So look at the color. It's dark in nature. On the top part, we see that it's glassy. But I kind of want to look at the main mass. And so if we look at it, you cannot see any grain sizes. And if you do, it's due to the reflection of the light. So, black in color, so this is mafic in composition. The texture is aphanitic. I'm gonna let you take a few moments to figure out this rock. Now, if you guess basalt, you're absolutely correct. Doesn't hurt to do one more. So, boom. Looking at this is pretty light in color, even though we have some black spots. Kind of want to look at the whole mass of the rock. Now, as you can see, it has extremely large crystal sizes where it's a few centimeters in length. So we can say this texture is pegmatitic. So we have a pegmatitic felsic igneous rock. Gonna take a few seconds to let you guys guess. Now, if you guess granite, you're absolutely correct. So for this part, I'm going to go through each type of rock that I have that is igneous base. So right here, this is rhyolite. We have a pegmatite granite, diorite, andesite, gabbro, basalt, dunite encased in some basalt. We have welded tuff, which is basically rock fragments inside or glued together by volcanic ash. Then we have more basalt, but we have porphyritic texture. Here is a pegmatite from Ray's Mine in North Carolina. And as you can see, there is a, I am blanking on what that mineral is. Apatite. So guys, hopefully you learned how to identify igneous rocks. If you have any suggestions down below, please place them down in the comments. Also leave a like. Let me know how you liked the video or not. Anyways, I hope you have a good day and rock on.